So for number 1 and 2, we just mentioned that those functions are so simple that we can't do much but use our calculator for them. And the only thing we could do is set our denominator equal to 0 to find our vertical asymptote. Number 3, though, there's a lot more we could learn from it because it's got a lot more things that we could use to kind of shortcut the process a little bit of having just to plug in so many numbers. Plugging in lots of numbers in a table and graphing them sometimes gets a little annoying. Okay, so here you got this equation. And you remember one of the things that we need to do when we get these equations is completely factor the top and the bottom. The top is it's just x minus 4. If I look at it as a factor, I might want to put those parentheses around it because my brain will process it in a minute better when I go factor the bottom. Now on the bottom, if you remember when we have these x squared minus 5x plus 4, these type problems where there's an x squared term but there's no number out in front of them except for that invisible 1 there, these were the easy ones to factor. And we would say we're trying to multiply to get the 4 on the end, the constant term here. I could label this thing ax squared plus bx plus c. I'm trying to multiply to get the c term. I'll write c there just so you remember that's what I'm trying to multiply to get. And I'm trying to add to get the same two numbers that multiply to give me that 4 have to add up to the number in the middle, the coefficient of the x term, which is negative 5. So that's usually we call that the b if we've labeled it. So what would work? What can you multiply to get 4 and add to get negative 5? Good. Negative 1 and negative 4. Sometimes those like that are hard for people to remember what to do, so that's good. If I factor that, I'm just going to write my top factor down. I'm just going to copy it. But on the bottom, what I'm going to have is x minus 1 for this minus 1 here, and x minus 4 for that minus 4 there. Yeah. Okay, so you start noticing there's things that are going to cancel out. And that's really one of the first things I want to look for is after I factored it is things that cancel out. And Charlotte, what canceled out? Okay. And when I say x minus 4 goes into x minus 4 one time, and x minus 4 goes into x minus 4 one time, what that thing that I just canceled out is, what's it called? It's called a hole. Remember when it cancels out? It's a hole in the graph if it cancels out. So in order to find out what?
I always think of that show, The Hole in the Wall.
Okay, so we're going to take that factor and we're going to set it equal to 0 to find out, well, what x would cause that to happen? If I solve for x and I add 4 to both sides, wouldn't x equal 4? That's where my hole is. I have a hole in the graph at x equal 4. That means there is no y value that goes with x equal 4. I'm going to be graphing my graph, and I'm going to come along, and all of a sudden I'm going to get to 4. I'm going to have to draw an open circle there and just kind of skip over it and keep drawing my graph. So we'll do that here in a second to see what that might look like. We just can't do it yet because we don't even have anything to put down on our paper for a graph yet. Now, if you remember, there was something else we talked about the other day, and that was asymptotes. Asymptotes are also places in the graph where x values don't have y's that go with them. Remember that when we plug these numbers in, what happens is we get 0 in the denominator. It makes an undefined fraction. That's why we have these things happen in the first place. It's because we get fractions with 0 in the denominator. So y'all remember, how did we find the asymptote? Yeah, the one in the denominator that didn't cancel out, and we set it equal to 0. Well, that's x minus 1. That's the one that didn't cancel out in the denominator. We set it equal to 0, and we solve. Oh, there's an asymptote at x equal 1. Okay, so already I've got some features about my graph that I know that I can place on the graph if I'm graphing, and I'll do that on another slide in a second. Now, because we don't know a lot about, there's some other things that I'm not going to teach you yet just because they come back and they teach them to you towards the end of this book, end of this chapter. There's something else, though, that I did teach you that the book doesn't talk about, and it's finding my x-intercepts. X-intercepts have always been important parts of the graph, haven't they? Like with graphing lines and things. They've always been important. They're still very important. And they actually kind of nice because it gives us a good, at least one good point where we could, get on the graph without actually having to go to a table of values. To get my x-intercepts, what I do is I set any factors in the numerator on the top of the fraction that are left equal to 0. Now look at my fraction. Is there any factor left in the numerator other than 1? There's just a 1 up there, isn't there? Right? Right. Okay, just make sure you're with me. There's just a 1 up there. There's not any kind of expression like x minus 4 left up there. It canceled out. Since there are no factors left, there's not going to be an x-intercept here. So there's no x-intercept. And also just know that when you work 1 and 2 in this same section, the same thing's going to happen because there weren't even any factors up there to start with other than just 1. So this thing that I'm telling you about is going to be important in the long run, but some of these are just not going to work out to have them yet, which is kind of unfortunate because that means I got to rely on a table of values to kind of help me graph this. Okay, his C, he's having us start to graph it, and he says draw a vertical dotted line at each discontinuity. I don't like drawing a vertical dotted line at the hole. I think that is going to confuse you in the long run. So here, let's do this. Let's kind of go ahead and, if you've got a graph, that I passed out that you want to use, you can use that. I'm just going to have to do this, though. This app doesn't come with a graph, unfortunately. I wish it did. Okay, so I know that I've got an asymptote at x equal 1. So here's my x-axis, here's my y-axis. Let's just assume we're counting by 1s on it so I don't mess up the graph on the iPad. At x equal 1, that's a vertical line through 1. We are going to put a dotted line on our asymptote, but let's not put a dotted line at our hole because I think that's just going to confuse you when you go to graph after we learn the other pieces of everything. I kind of think if I had been told to do that, it would have really messed me up. So what am I going to do now? I don't have any x-intercepts. Nobody's told me about horizontal asymptotes yet, which comes later in this chapter and is a little bit more complicated than this. So what am I going to do? I'm going to have to go to my graphing calculator, which is really what he was having you do in 1 and 2. And it looks to me like, let's kind of make a table of values here. And I'm going to need you guys to plug this into your calculator and tell me what values you're getting, because I'm focusing on recording instead of... We're going to need quite a few here to get the shape of this graph, probably. And I always want to know what's going on the other side of this asymptote. That asymptote's at x equal 1. So I probably should plug in a point, like it would be good to get what's going on when x is 0. And what's going on the other side of that, the next whole number, is 2, right? But even more than that, I kind of even want to get closer in than that. I want to plug in things like, well, what's just barely past 1? How about 1.1? What comes right before 1? What's the decimal value before 1 if we're counting by tenths? Would it be like 0.9? Okay, so that would be good, but then I kind of need to know other stuff too. I need to know like maybe what's going on, maybe a little further out. Let's see, 2, 3, 4. Maybe I want to know what's going on at x equal 5. Maybe I need to know what's going on here at x is negative 1. Maybe I'd want negative 5 or something. So what we're going to do is we're going to go put this in our calculator, this equation, and we're going to look at the table of values. And remember, when I do that, one of the most convenient ways to do that, since I've got these decimal values, is to go to the table set, which is above what window? I think you hit second window. And we're going to go down to where it says independent value, and we're going to highlight the word ask just on the same line as independent value and hit enter. And then I'm going to hit second graph and go back to my table, and I'll be able just to type these numbers in and get some good values. It's not that I can't use the values the calculator generates, but how am I going to get that 1.1 and that 0.9 values? The calculator's not going to tell me that unless I want to. I could tell it to count by 0.1, but it would mean we do an awful lot of scrolling that gets kind of annoying. Okay, now this might not even be enough values, but it's at least a starting place. If I type in x equals 0, I'm getting negative 1. So I'm going to graph in red. 0, negative 1 would be here. Let's type in 2 since I put it in my table next. Oh, I get 2, 1, so that's going to be like right here. Let me type in 1.1.
Okay,
So we can kind of start seeing some things that are going to happen. If we type in 5, just to get a better picture, we get 0.25. And again, if you're following along from home, make sure you're actually getting your calculator out. Don't just write this stuff down or it ain't going to make any sense. That'd be about a fourth, so it's going to be about right here. That's supposed to be a -1. It's at -0.5 at -1. So -1, -0.5 would just be, slightly lower there. And then at -5, I'm getting like -0.1667. So it's like at -5, 1, 2, 3, 4, 5. It's like down between 1 and 2. Let me look. No, it's even closer in to the x-axis there. It's actually this top point that I graphed. I touched it with the stylus. If you were to connect these points, remember there's a point down here at the very bottom. I'm darkening it so you may be seeing it spread out a little bit. I'm drawing it really big. Bless you, if I were to connect these, this is what's going to happen. It's going to come down here and drop down way down. This is called a branch. And up here, if I were to connect these, I'm getting something like this. Come on, iPad, I'm drawing, pick it up. I'm getting something like this. And you can check your calculator and look at it, and that looks what, in your calculator, do you see how when it gets so close to the x-axis, they just kind of almost looks like it joins into it? Those what we see is the x-axis is what we call a horizontal asymptote. It's never going to touch the x-axis either. We haven't figured out the fast way to find the horizontal asymptote. We will, but it's just not as simple of a thing as what we just did. So they're going to save that for later. So they're kind of teaching you a little bit about graphing it. You're relying heavily on points at this point in the game. And then, they're going to come back later and tell you a little bit more. It's going to help you a little bit, use a few less points from your calculator. But really, either putting the points in by hand or from the calculator are still an important part of this, just so you can get the shape of this. These two little L kind of shapes are called, again, they're called branches of this. This is a rational equation graph. This is pretty typical of what they look like. And they have these two kind of branches, we call them.